Hello everyone. Today our team will show you a magnificent application which can help drivers make better decisions to drive safer. Although driving a vehicle brings a lot of convenience and fun to people, risks and losses are also exist at the same time. The traditional navigation system can actually help people plan the routes to their destinations. But the traditional navigation system cannot help the driver avoid risk in the driving process. Moreover, the way drivers interacted with their systems during driving can increase the probability of some accident. The more direct interact methods such as augmented reality can avoid this problem. The term augmented reality was coined by Tom Cardell in 1990 as a technology that can blend physical environment and digital environment. It was not implemented by limitation of hardware performance and technical problems until the public announcement of Glass in 2012. Through years of continued development since then, the technique and product are mature, especially the release of Microsoft HoloLens. Based on a wall, the combination of AR and navigation system on wearable devices is a good method to build application to enhance driving safety. In our application, we designed and developed an augmented reality navigation and auxiliary system on smart glasses. This system not only provides a more intuitive way to navigate a route, but also offers several additional auxiliary systems to help drivers drive safely.
The main feature of our application is an augmented reality navigation system. This system gives users a better route to the destination and uses voice control to set destination. This design is made to keep drivers' hands on the steering wheel and eyes on the road. To prevent accidents happen by driver's distraction, our application projects a semi-transparent blue arrow of the best route into driver's glasses. It can allow driver keep his eye on the road while know the path in the same time.
In addition to an AR navigation system, we also developed an AR driving auxiliary system to help drivers drive more conveniently and safely. The AR driving auxiliary system includes vehicle safety, distance calculation, dead zone recognition, dynamic hazard recognition, and parking place finding and started vehicle detection. Let's look at this slide. When we are driving on a highway, we should maintain a safe distance from vehicles in front of us. This safe distance is about 100 meters to 150 meters. Keeping safe distance can effectively avoid the rear-ending collision if the car in front of you suddenly slows down the speed. However, it is difficult for drivers to determine this distance only through their eyes, and they often do not protect the safety car distance when they are driving in the highway. So in our AR driving auxiliary system, using the technology of AR and the 3D depth of field measurement, the information of the distance and the speed of car ahead will be directly displayed on the smart glasses so that the driver can easily maintain a reasonable distance to the front car. This can greatly reduce the occurrence of rear-end accidents. For the driver sitting in the driver's seat, there exists a driving dead zone. This dead zone is the place where blocks the driver's side. Most of the dead zones inside the car are due to the structure of the vehicle, and most of the dead zones outside the car are due to the moving object or the change in light. For inexperienced drivers, these blind spots can easily cause traffic accidents. Therefore, a dead zone recognition auxiliary system is necessary. As shown in this picture, if someone moves from the blind spot to the front of the vehicle, our system will calculate the walking speed of the pedestrian and provide an approximate location of the pedestrian in the dead zone to avoid accidents caused by the drivers who does not notice the pedestrian in the dead zone. In addition to capturing and analyzing the image data through the camera, the system will also access and analyze the sensor data from the vehicle. Through the vehicle's radar sensor and the ultrasonic localization algorithm, the object distribution around the vehicle can be displayed in the driver's line of sight, so that the inexperienced drivers can know all the objects around the vehicle. Driving vehicles, sometimes like life, will encounter some unknown situation. At this moment, it tests the driver's experience and rapid response capability. However, not every driver has such a sophisticated experience and keen sense of responsiveness. As a result, inexperienced drivers are often at a loss when they encounter such situations. Therefore, our driving auxiliary system also provides a dynamic hazard recognition to help drivers make the right decision. As shown in the picture, when a vehicle is suddenly backed up in front of the road you are driving on, our system will calculate the speed of the target vehicle, the speed of the current vehicle, and the distance between two cars. At the same time, according to the environmental factors around the driver's vehicle at that moment, our system will propose driver to brake the car or change the lane. By such proposal, the accident risk caused by the emergencies will be reduced to a minimum. This function does not only provide the guarantee for the driver's safety, but also gives more confidence to the novice drivers. Through the image recognition algorithm and AI technology, when the driver is finding a parking space in the parking lot, our system will find the location of the parking space and present this information to the driver's eyes. This will help the driver quickly locate the suitable parking space, and our system also uses a piezoelectric infrared sensor to do the thermal imaging by identifying the heat inside the car to recognize whether there exists a started vehicle nearby or ready to go to prevent the risk of the collision.
In order to gain requirements our application needed, both interview and ethnography were used as our research methods. We did the interview to gain the potential requirements and using the ethnography to justify whether the requirement is really needed in our application to give people a safer future. In the process of understanding application core requirement, we also identified the sensor we needed: GPS, radar, and the piezoelectric infrared sensor. For the evaluation of our system, we divided it into several parts. For the assessment of the route planning of our augmented reality navigation system, we established a standard test set of the best navigation route, about 100,000 routes, using our system to do the route planning for these test sets. After comparing, more than 98% of the route plans through our system is the same as the best route in our test sets. In this way, we can think that the route planned by our system is an optimized route. For the recognition system, we built a CNN model to test it and calculating F1 score to finalize the result because we think both precision and recall are very important.